Hey guys, welcome back to our JavaScript series. In this video, we're going to talk about type conversions in JavaScript. So let's get started with this video. Now, type conversions is a very important topic to understand because see, sometimes what happens is that you won't even know and the conversion of data from one type to another would happen. For example, in case of implicit type conversions, uh, if there is a difference between the operand type it expects and the operand type you're passing, then it's gonna cause a conversion of the data that you have passed to another type, and something weird can happen. And that is why it is very important to understand the rules of implicit type conversions so that you are very careful while you are writing your code and you know when implicit type conversion can occur, and you can save your code from uh, getting and you can like save your code from getting issues from that. So that is what we're gonna see today. So as you can see, there are like two types of conversion: implicit type conversion, explicit type conversion. Implicit type conversion basically means automatic type conversion, in which automatically the type gets converted to another type. Obviously this is risky and tricky because you might not know, if you don't know these rules, you might not know when your type, when the data you have passed might change the type, and then you would realize it, and there might be some bug because of that. So that is the thing about implicit type conversion. Explicit type conversion, on the other hand, is very easy and straightforward because you are the one who commands JavaScript to explicitly convert type from one type to another, right? Explicitly convert the data from one type to another. And so let's first understand about implicit type conversion. I'm just gonna talk about some operators and the implicit type conversion things that happen with them. First is arithmetic operator. These are all the arithmetic operators, by the way, we have. So let's see the implicit type conversion in these cases. So let's first of all talk about binary plus. Now I have just these examples over here, which I've directly copied. Let's see this. So Coca.js, and let me take it over here. So if you see this, the answer for this 1 plus 2 is 3, which makes a lot of sense because you're passing like both of these values as numbers. So it's just gonna add it. In case of plus operator, you pass both of these. In case of second example, you pass both of the operands as string. So it concatenated that instead of adding that. In the third case, you did a mix of that. You passed a number operator, you passed a concatenation operator. Now, in this case, from the operators lecture, I told you that the concatenation would happen. But concatenation won't have happened if the implicit type conversion didn't occur, because you are passing both operands as different of different data type. Now the issue comes, will you add these things? The answer is you can't, because my is a string. Although you can convert it to a number, I would tell you the cases in which it can be converted to a number, but it's something, it's one of the things that can happen. Or you convert two into a string so that both of these things can get concatenated, and here the type conversion happen, implicit type conversion happen. Two gets converted to a string and then gets concatenated to form my two. Okay. Then let's take one more example over here. You can see these were two like numbers inside a string. They didn't got converted into a number. They directly got concatenated and got the result as 24. Same in this case, type conversion happened. 4 got converted into a string, and then it just resulted into 24. So you can see, if even if like one operator is string operand, one operand is string operand, then the other operand would automatically get converted into string operand in case of binary operator, binary plus operator. Okay. Let's talk about unary plus operator now. So unary plus operator is, as I said, like it's mostly useless, but in case of type conversion, it's helpful. So you can see over here, it is helpful for converting something into a number. For example, you can see plus 4 basically gives you 4, which is a number, not an issue. But if you do plus 4 on a string having 4 inside it, then it actually becomes 4, right? So it actually becomes 4 over there. And you can actually check that it is a number by just doing type of, and you will see it's a number, right? So it basically get converted into a number because you put a plus operator, unary plus operator on that. Okay, because see, unary plus basically tries to combine with the operator of the number itself and then create a new number. In this case, the operand was not a number, so there was like a operand mismatch, and that's why this was converted to a number, because this operator always expects a number. It never expects string, for example, right? The same goes over here. You can see it got converted to a number -4. You can check the type from here. But in case of this, you can see string was not an actual number, but you gave a plus, so implicit type conversion occurred, and you got not a number, which is also a number. But this is one of the ways in which you can produce not a number, right? You can't go and do this kind of stuff. It's not possible, and so that's why you got not a number, right? So let's see the next example where we're going to talk about all these other operators. So let's get that here. So you see this one, for example, this is all fine. 2 multiply 4, that gave you 8. Okay. If this was the case, you can see 2 and 4 actually got converted to a number, and then the multiplication happened. Okay. So again, an implicit conversion. In case of binary plus, if both were strings, it would have concatenated them instead of converting that to a number. Even when both can be converted to a number, like these two strings can't be converted to a number, right? If they are converted to a number, they would result into not a number. But in this case, it could have been converted, but it still didn't got converted in case of binary plus. But in case of multiplication operator, for example, it got converted easily. Okay, even when both were strings. And if one was string, obviously it would get converted and you get the answer as 8. Okay, because see, plus has two use cases. One is arithmetic and one is string case. So that's why it was able to even survive in case of not converting a string into a number. But multiplication, division, subtraction, um, exponentation can't survive with the string, and so they have to convert it into a number to get the operation done. And sometimes the string can't be converted to a number. For example, in this case, string can't be converted to a number. Okay, and that's why it got converted to not a number. Okay, which is also a number, but not a number multiply 4 would give you not a number, because if you try to do any arithmetic operation with not a number, that's going to yield you not a number. So you can see some examples over here. All the operation basically gives you not a number. Okay, so that is basically the thing that happened with these operators. So this operator prefers string, kind of prefers string, like not always. If both are numbers, then it doesn't prefer string. But this operator always prefer number. It doesn't prefer strings at all. And by the way, I'm talking about binary negative over here. I'm not talking about binary unary negative. Unary negative has a separate thing. It has a separate logic on it. So if you see this, -4 would basically give you a number -4. If you try this on this, you can see it basically behaves just like plus unary operator. It converts it converts a string into a number. So in this case, it converted into a number -4, right? You can check the type of that, and it's a number only. Minus, then you converted -4 that was inside a string by using unary negation, and that basically give you 4. Why that happened is because minus 4. Now -4 inside a string would get converted to a number, so implicit type conversion would happen, and you get this, and that would basically give you 4, right? Basic maths rule here: negative negative becomes positive. Basic maths. And yeah, that's a number. Just to verify, you can see it's a number. um, then if you check minus ABC, that gives you not a number, because ABC can't be converted to a number. This unary negative, unary positive always try to convert a string into a number. That's the advantage of these operators. Like unary negative has one more advantage of converting a negative number into a positive number, Like if it's negative, if I say negative 4, that would convert to 4. Actually, I should do like this. Yeah, negative 4 that got converted to 4. That's one more use, obviously, but binary plus only has sorry unary plus only has this thing, only has this use, that it converts uh, a string that has a number inside it to a number. um and you can see the other examples over here. Let's talk about boolean now. So boolean has a very interesting rule that um true is basically 1 and false is 0. So this is something you can just memorize, that true is equal to 1 and false is equal to 0. Some examples for that I can show you. So if you go and say true plus 0, that would give you 1 plus 0, that would become 1, because true would get implicitly converted into 1. See, plus operator can never tolerate um, this boolean. It can only tolerate the string or a number. Okay, and so here it was passed a number, and here you passed a boolean value, and so it got converted into a number 1, and then added with 0, and then you got 1. Right. The same goes over here. This would result 2. This would result 1, and over here you can see a very complex example, right? Actually, let's try to make it even more complex by adding a divide over here, and minus over here, and maybe a plus after that. Okay, now let's see what will happen in this case. So this is a very complex example, so let's actually see it over here. Yes, so in this case, uh, wait, I didn't copy it. Yeah, there we go. Now, in this case, first of all, the exponentation would have to be solved. But actually, before that, I just saw there's a grouping operator, so I have to solve it first, right? So true divided by true. So implicit conversion would occur 1 divided by 1, and then the rest would be the same. So let's copy that and paste it over here. So next, this would become basically 1. And by the way, we can also solve this side by side, because again, grouping operator has like same precedence over here, so we can solve it together left to right. So over here, and actually in grouping operator, I think the associativity is not applied, which means that you can solve any grouping operator first, grouping operator and expression first, doesn't matter. You can solve this first or you can solve this first. So I'm just going to solve it parallelly. So over here, first of all, we would solve this, because this is what is more important over here. Multiplication has higher precedence, so 2 would become first of all 1, and now let's solve it on the next line. So this would get solved into 1 exponent operator, and then we would go and say 1 multiply 4, that would become what? That would become, and actually, yeah, actually, let's do that only. 4 minus, and then false would become 1 actually, or maybe I can do it over here, 0. Sorry, 4 minus 0, and then this would get converted to 1, so plus 1. Okay, now let's see over here. So over here, we would again solve this one. So I can just go and say 1 exponent 4 plus 1. So finally over here, we would solve this first. So 1 to the power of 4 would become 1, plus 1 would become 2. And so that's why we're getting the answer of 2. So I hope that is very clear to you. And that's the rule between in Boolean values. Okay. Let's talk about null and undefined now. So null and undefined basically is very simple to understand. Null gets converted to 0, undefined gets converted to not a number. This all happens when you use an arithmetic operator, because arithmetic operator expects either like a string or a number, right? Um, and only actually like string is only accepted by arithmetic plus operator. Okay, arithmetic binary plus operator, and unary plus and negative operator. Anyways, let's paste this over here. So you can see over here, 1 plus null. So null gets converted to 0. So 1 plus null becomes 1 plus 0. That becomes 1. 4 multiply undefined. Undefined becomes not a number. So 4 multiply not a number becomes not a number. I hope that is very clear to you. That is how the type conversion, implicit type conversion happens over here. So you can see one pattern over here. I didn't got even a single error in JavaScript, even when I'm doing these weird things. Okay, so that's the thing about JavaScript. You can say it a beauty of JavaScript. I believe it's a really bad thing over JavaScript, because this can lead to a lot of bugs. But it's how JavaScript is, right? So you have to understand about implicit text conversion for that reason, because you can actually do these kind of things and you won't even know that you're doing these kind of things. So you should be very, very careful about it. And JavaScript doesn't stop you at all. It would just give you things like not a number, or like other random strange values, so that it basically suppresses the error that it could have produced. Okay. Finally, we're going to talk about conditional operator and not operator. By the way, we're not talking about type conversion in case of logical operators, because they kind of doesn't do that. If you try to use logical operators with the non-boolean value, that's going to lead to short circuiting. So I've already told you about that in the logical operators part of operators lecture, that if you try to use a non-boolean operands, it's gonna cause it's basically going to cause short circuiting. Okay. So this is not something we are going to discuss in type conversion because of that reason, because it's not a type conversion at all. It's short circuiting. That's a different topic. So we're going to talk about that in a different lecture. Anyways, let's talk about this conditional operator and not operator. So one thing you need to understand that, okay, if you pass like false or true value in the conditional operator, so let me actually go and again get the conditional operator syntax. So Boolean expression one. Actually, let's just make it A, B. So you already know if Boolean expression is true over here, then you get A. If Boolean expression is false over here, then you get B. Okay. So, and then obviously for not operator expects a Boolean value over here. Okay. So it reverses Boolean value. Now, what would happen if you try to pass a non-Boolean value over here? Or if you try to pass a non-Boolean expression over here, an expression that doesn't give a Boolean value, then what would happen? In that case, type conversion would happen and the value that you have passed would convert into a Boolean value. So, and that is where you need to understand that the um, 0, 0n, empty string, null, undefined, not a number, all converts into false if used instead of Boolean expression over here. I hope that makes sense. And any other value other than this becomes true. So let me show you one example over here. So some examples, not just one example. Obviously, we should cover a lot of examples for this. So that's very, very clear. So first of all, I'm talking about the ternary operator. So you can see over here what happened. I passed 1 instead of true or false. So 1 is true because it doesn't lie in this group. So that's why it got converted into true, and true on this would basically give you A. It's very easy to understand because you already know about ternary operator. If you don't know, watch the operators lecture. It's very important to watch. Otherwise, you won't understand anything I'm teaching in type conversion lecture. Over here, you can see I passed again an expression that would that when evaluated would return a non-boolean value, in this case 0. 0 lies in this category, and so it would give you false, and so you would get the answer of B. Okay, so this whole flow is explained over here. Next, this over here, for example, gives you empty string, because empty string is basically false, and so that's why it returns and that's why it's converted to false, and it shows you this instead of this, whereas this gets converted true, and and therefore you get this. Okay, now let me show you one more thing over here. Some people might assume that this is if this is like a if this is like false, then this might also be false, but the thing is that this is not false, because it's having some character. A string that doesn't have any character is false. But if a string has even one character, or like even has a white space only, that is also considered a true value. So let me show you. I can see not empty string. Okay, because it's a true value, and so that's why you got this. Next, let's discuss about examples for not operator. So again, it's very easy to understand this. If you try to go and see these examples, First example over here, you passed an empty string. Now, empty string is basically what? Empty string is false. So not false. Actually, let me write it down completely. So not false would give you true, which is very easy to understand. Next example, not ABC. So not ABC over here. So ABC gets converted to what? ABC would get converted to true because it's a string with some value. So true not would become false. Finally, this zero is basically what? Zero is false. So not zero would become not false, and not false would become true. And that's why you got true. So I hope implicit type conversions are clear. It's very important to understand that. So it's not, if it's not clear, do let me know in the comment section below. I would love to answer that, but you should always go and ask it if you're not clear about it, because it's a very important thing to discuss and it's a very important part of your JavaScript journey. Next, we're going to talk about explicit type conversion, which are very, very easy. And so I'm very excited to talk about it. First, we're going to talk about explicit type conversion for string. So by the way, what I mean by explicit type conversion, you already know. Explicit type conversion means that you manually do the type conversion. So basically I command JavaScript to convert a value into any other data type value. So you can see some examples over here. And by the way, to do the type conversion, to do the type conversion of a value explicitly, you for a string, for example, if you want to convert a value into a string explicitly, then you need to go and say string, and then you need to give a parenthesis, and then inside those parentheses you can pass the value, and the value that would be returned would be a string value. Okay. So I've shown you some examples over here. Um, Obviously, like if you say 2, that's basically type of its number, so it's a number. But if you do string 2, that gets converted into a string with the number inside it, but still a string which you can check from type of. Same over here, you can see other examples. This gets converted to -2 inside a string. True get converted into true, but true gets inside string. So actually, like string one is very easy. Whatever value you're passing inside the string parenthesis inside this would just get inside string directly as it is. For example, here true gets as it is inside the string, false get as it is inside the string, null got as it is inside the string. Undefined also got as it is inside the string. Even not a number got as it is inside the string. So that's how easy it is to convert a data type into string. You don't need to remember too much over here. You know, if you pass a value, if you explicitly convert a value into string, that would just become the same value, but that would be inside string. So that's the thing about strings. It's string explicit type conversion. Now let's talk about number explicit type conversion. That is kind of tricky here. So we need to understand that as well. So here I can just paste the examples. So you can see over here, the first example, I have a string over here. The type of I can confirm from there. That has a number inside it, by the way. I convert it into a number, and then when I check the type of, it becomes a number, as you can see, right? One more thing over here, I can pass a string with a number, and that string might have a lot of white spaces here and there, but that won't matter. It would still get converted to a proper number without any issues. You can see it's getting converted to a proper number without any issue, even when it has some white spaces at the start and the end. Same goes for negative number. You can see I converted a negative number into like a negative number inside a string into a number easily without any issues. Same goes with floating point number, that also gets converted easily. Okay. Then you can see begins. If you try to convert begin number into begin into a like a begin into a number, you can see you're getting not a number. So why this is happening? The reason is that if you go and say string 4n, that basically gives you 4, because see, the thing is that inside a string you can go and you can go and accurately store any number. Like, doesn't matter how big that number is, you can easily go and store that number inside a string without any kind of issues, and that's why it's working over here, right? So that's the thing, it's working fine because you can store accurately any number, any big number inside it, and that's why when begin is converted to into a string, it just gets stored directly. Okay. So yeah, that's the thing. um Let me show you the next thing over here. So yeah, because of that, it just doesn't get converted into a like a proper number properly, right? Then let's talk about this example over here, you can see again negative numbers can also be like converted like this, where we have like a lot of white spaces at the start and the end, doesn't matter. But one thing over here, if you try to add some white spaces between the negative number and the negative sign and the number itself, it's gonna cause not a number. And actually the same would apply even when you apply spaces between the digits for the number. For example, if you say 30 and then you say 2, you can see it's basically give you not a number, right? So that's very important to understand. Next is true. So true gets converted to 1, false gets converted to 0. So this must sound very familiar from this, right? Very easy to understand. Then null gets converted to 0. Again, very familiar from this. Undefined gets converted to not a number. Again, you must be familiar with this. Um, and then finally, if you see empty string gets converted to a number, right? So it became 0. If you have an empty string, that becomes 0. And empty string but with white spaces get converted to 0. Okay, so that's also very important to understand. Okay, so now let's talk about boolean conversion, boolean explicit conversion. Again, that is very easy to understand. If you just have a look at this rule, uh, this rule basically summarizes all the thing. Okay, 0 gets converted to false, 1 gets converted to true, -1 gets converted to true, even exponent numbers get converted to true, 0 and gets converted to false, a begin number that is not 0 and gets converted to true, this gets converted to false, true, true, and true, and then also true. Okay, so I hope that's very easy to understand. I think that's all about implicit explicit type conversions. I hope you understood all these things over here. So yeah, that's all for this video. If you have any doubts, you can post that in the comment section below. I will see you in the next one. Bye.